MGF 1106 final exam review. Question number 53, we're dealing with a volume of a shaded solid. So again, this is going to be a multi-step problem. We are first going to find the volume of the outside figure, which is a cylinder. Second, we're going to find the volume of the inside figure that is not shaded, which is also a cylinder. And then our last step will be to subtract the two. First things first, please always make sure your units are all the same. They are. So we are now going to break this problem into several steps. Okay. Remember, a cylinder has two bases. So the volume formula is area of the base times the height. So in this case, it's going to be base is a circle, so it's pi r squared times h. That is the formula we're going to use for both shapes in this problem. So number one, we're going to use the outside cylinder. So first things first, we need to be careful. The outside cylinder that we have here, the diameter is 18, so my radius will be 9 feet. Okay. My height of the cylinder is 30 feet. So I'm now going to plug it into my formula. Let my calculator simplify for me. 9 squared is 81 times the 30. So my volume is 2,430 pi. That's the exact answer. Again, this problem actually does have us rounding if necessary. So that's my volume for my first figure. My second figure, inside, is going to have a radius of 3 feet, because this is the diameter. Height, 30 feet. So we're using, again, the same formula. Pi times r squared times the height. So I get 9 times 30, which gives me 270 pi for the volume of the inside figure. So my last step here is to subtract these two shapes, because this is the piece I do not want to include. So I have 2,430 pi minus 270 pi. The exact answer would be 2,160 pi. But looking again, this is round your answer to two decimal places if necessary. So we're going to use the 3.14 for pi. So my approximate answer, 6,782.4. And again, this is volume, so it's feet cubed. First step, volume of the outside cylinder, which is here in red. Second step, volume of the inside cylinder. Last step, subtract the two and round if necessary. Going to number 54, we're dealing with a rectangular building. We have 80 decimeters, 6 meters, and 7 meters high. So we are dealing with a volume of a rectangular solid, which is length times width times height. But this is where you have to be careful. Not all of the units are the same, and they want it in meters. Okay, specifically meters cubed. So this piece here has to be converted. Looking at your units, again, looking at the order of the format that you have, okay, decimeters is 1 unit to the right of your base. This is where you have to be careful between deca and deci. It has base unit, you have deci, over here you have deca. You've got to make sure you know the difference here. This would be decimeter. So you're going 1 unit to the right, okay, if you're going to decimeters, but we are going from here to the base because we're going decimeters to meters. So 80 decimeters is going to go 1 unit to the left, which gives me 8 meters. Step 1, if you don't do that, you're going to get the wrong answer. At this point, my units are the same. I can plug in. So length is 6. Okay. My width is 8 now. My height is 7. 6 times 8 is 48. Times the 7 gives me 336 meters cubed because my units are all the same. The key piece is converting, and it's easy to misread this. Every single problem dealing with area and perimeter and volume, you must check to make sure your units are the same on step 1 and their units are what they would like at the end of the problem. In this case, metric, you're just moving your decimal. Deci is going 1 place to the base, which this is again your meters. Answer is 336 meters cubed.